Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is a problem on uh, couples. The drive shaft applies a torque M1 which is 5 kilonewton meter to the gearbox, and the driven shaft applies a torque M2 15 kilonewton meter as shown. So determine the resultant couple acting on the gearbox, specifying its magnitude and its direction angles with respect to the XYZ coordinate system. So here's the given figure. So if you apply the right thumb rule, your right thumb towards this axis here, your four fingers will curl in the same sense as M1. Therefore, M1 is positive and it is 5I kilonewton meter in vector form. While M2, if you position your right thumb towards the positive uh, y-axis, then M2 opposes the positive sense of moment. Therefore, M2 is negative 15 since it acts about the y-axis, so it is negative 15j. Therefore, the resultant couple in vector form is 5i minus 15j. So for the solution, moment equals 5i minus 15j kilonewton meter. The magnitude of the couple is square root of 5 square plus 15 square. So it is 5 square root of 10, approximately 15.81 kilonewton meter. Then for the direction angles, cosine of theta x equals mx5 divided by m. So in vector form, this is our answer, quantity 5i minus 15j kilonewton meter with a magnitude of 15.81 kilonewton meter. For the direction angles, cosine theta x equals 5 over 5 square root of 10. So theta x is equal to 71.57 degrees. Then cosine theta y is negative 15 over 5 square root of 10. So theta y is r cosine of negative 3 over square root of 10, or that would be 161.57 degrees. And cosine theta z is 0 over 5 square root of 10. So r cosine of 0 is 90 degrees. So theta z is 90 degrees. Then for your part, here is your problem. Determine the couple that is equivalent to the effect of the four forces acting on the rectangular post. So show that the answer would be negative 2,400I plus 240J minus 20K pound-inch. Problem 89, still on couples. The four forces acting on the rectangular parallelepiped are equivalent to a couple M. Determine the magnitude of F, the angle alpha, and M. So here is the given figure. These are the four forces. This is the fourth, which is unknown, F, and the angle that F makes with this horizontal edge, which is the y-axis, is alpha, and it is directed backward and leftward as shown. So let's superimpose the reference frame, XYZ frame, so that will be guided in our solution. So since the effect of these four forces is equivalent to a couple M, it implies that there's no resultant force, and that is Rx is 0, Ry is 0, and Rz is 0. So R sub x equals 0, then it is equal to positive 5 minus 3, then minus the x component of f, because this is alpha, it is f sine of alpha in that direction. So f sine alpha equals 2, call that equation 1. Then Ry equals 0, and it is equal to 6 minus the y component of f is f cosine of alpha. So Ry equals 0 equals 6 minus f cosine of alpha. F cosine of alpha therefore is equal to 6. So that's equation 2. We can now solve alpha if we divide equation 1 by equation 2. So f sine alpha over f cosine alpha is tangent of alpha, then it is equal to 2 over 6. So tangent alpha equals 2 over 6, so alpha equals arctan of 1/3. 2 over 6 is 1/3. So 18.435 degrees. Then substitute into equation 2 to solve for the magnitude of f. So f cosine of 18.435 degrees equals 6. So f is 6.325 kilonewtons. The next is the magnitude of moment. So let's have right thumb rule and scalar approach. So moment about x, your right thumb is here, so the curling of the four fingers is in this sense. So this is the positive sense of moment about x. So 6 will produce positive moment about x. It is 6 times this distance, which is 0.15, and the rest 0. Moment of f is also 0 because it crosses the x-axis. Now, you can actually sum up moments about any superimposed coordinate axis because moment is independent of the moment center. You may have it here, so I put it there so that this f here, which is an unknown, will not be involved always. So again, mx is 6 times 0.15 only, and it is equal to 0.9 kilonewton meter. My, so your right thumb is towards the positive x-axis. The curling of the four fingers would be in this sense. So this is the positive sense of moment. This is the arrow. So this is 0, 0 because it is parallel, 0 because it acts on the y-axis. Only 3 kilonewton will have moment about the y-axis, and it is also positive. See? So positive. So moment about y-axis is 3 times also 0.15. So it is equal to 0.45 kilonewton meter. And finally, moment about the z-axis, your right thumb towards the positive z-axis. The curling of the four fingers would be this. So this is the positive sense. So 6 would be positive. Moment arm is 0.1. 3 is also positive. That sense. Moment arm is 0.2. While 5 is negative, it opposes. Moment arm is 0.2. So moment about the z-axis is 6 times 0.1 plus 3 times 0.2 minus 5 times 0.2. So mz is equal to 0.20 kilonewton meter. So therefore, the moment, the magnitude is square root of 0.9 square plus 0.45 square plus 0.2 square. So the magnitude of the moment, the effect of these four forces to this rectangular parallelepiped body is 1.026 kilonewton meter. Then here is your part. Determine the couple that is equivalent to the effect of the four forces acting on the wide flange beam shown. So I want you to show that the answer is moment is 0.200 I minus 0.395 K kilonewton meter. Two cables, each carrying a tension of 3 kips, are fastened to the crate. The effect of these cables and the force F acting at corner A is a couple M. Determine F and M. Here is the given figure. So F is directed anywhere, so we'll just assume that it has 3 components. So 3 kips. For the solution, let's resolve its force into components. So this has Y and Z components only. Y is positive, Z is negative going down. So this is 3 cosine of 45, while this is going down 3 sine of 45. And here we have to compute this component first. It is 3 cosine of 36.87. Component on the XY plane is 3 cosine 36.87. Therefore, the X component, which is in this direction, is 3 cosine 36.87 times sine of 30. That would be 1.2 kips. Again, 3 cosine 36.87 times sine 30 is this component here, which is equal to that. So 1.2 kips. This component along Y is 3 cosine 36.87 times cosine of 30. So that would be 2.078 kips. While this component, which is downward, is 3 kips sine of 36.87 going down. And that is 1.8 kips. 1.8 is again 3. The tension here is 3. Then sine, the vertical angle is 36.87. So 3 sine of 36.87, 1.8 kips downward. So if the effect of this, the forces in the cable as well as F is a couple, purely a couple, so that means Rx is 0 and it is equal to Fx plus 1.2. So Fx is negative 1.2 kips. Ry is 0 and it is equal to Fy plus 2.078 plus 3 cosine 45. So Fy is negative 4.199 kips. Then Rz is 0 and it is equal to Fz minus 1.8 minus 3 sine of 45 degrees. Minus Fz minus 3 sine 45 degrees minus 1.8. So Fz is positive 3.921 kips. Therefore, in vector form, the force F is negative 1.2I minus 4.199K plus 3.921K kips. Negative 1.2I minus 4.199J plus 3.921K kips. So that's F. Then for M, let's superimpose the XYZ here so that many forces will be uninvolved. So, by the way, this is Fx, negative 1.2, so backward. Fy, leftward, 4.199. Then Fz, upward, 3.921. Then let's superimpose the XYZ reference. So here, so moment about X, the positive sense is in that sense, since this is the x-axis, all these forces are not contributing to moment about X. This is parallel 1.2, so not contributing. 4.199 passes through this x-axis here, so also not contributing. So only 3.921 will have moment about X. And since this is the positive sense of moment, then the moment of 3.921 is negative 3.921 times 5. So that's the positive sense of moment about X, positive sense of moment about Y, and positive moment about Z by right-hand rule. So mx is due to 3.921, but it is negative 3.921 times 5. So negative 19.60 keep put. My, this is the positive sense, so all these three forces will not be involved. So here it's parallel, not involved. So 3 sine 45 is involved. And 4.199 parallel, 1.2 passes through or acts the y-axis, not involved, as well as 3.921. So only 3 sine 45 is involved because this is the y-axis and this component is parallel. So 3 sine 45. This is the positive sense, but the moment of 3 sine 45 is in the opposite direction. So therefore, it is negative 3 sine 45. This is the moment arm, which is 3 feet. My equals negative 3 sine 45 degrees times 3. And it is negative 6.364 kip foot. Then moment about the z-axis, this is the positive sense. All these three are not involved. Vertical forces not involved. 4.199 passes through the z-axis, not involved. So there are two forces that must be considered, 1.2 and 3 cosine 45. All these produce negative moment because this is the positive sense and the moment of 1.2 is in that sense, so negative. The moment of 3 cosine 45 is also in that sense negative. So negative 1.2 times 5, negative 3 cosine 45 degrees times 3. So that's the moment about z. Negative 1.2 times 5, negative 3 cosine 45 degrees times 3. And it is negative 12.36 kip foot. Therefore, in vector form, moment m is quantity negative 19.6 I, negative 6.364 J, negative 12.36 K kip foot. So that's it for this problem. And for your problem, this is your problem. A dirigible is tethered by a cable attached to its cabin at B. If the tension in the cable is 1040 newtons, replace the force exerted by the cable at B with an equivalent system formed by two parallel forces applied at A and C. Since the force or tension in BD is 1040 and it is in that sense 60 degrees, so the forces at A and B will be parallel to this, so it will have an angle of 60 degrees below the horizontal also. And show that these are the answers. FA is 388.8 newtons, 60 degrees below horizontal, parallel to tension in BD. And F sub C 651.2 newtons at 60 degrees below horizontal also. So that's it for your part.